As I build this project, I will explain every line of a code in a simple way, especially for beginners like me. If you are just starting with machine learning, this series is for you. Many beginners search for datasets on Google, Kaggle and other websites. But today we are going to do something different. Instead of downloading a dataset, we are going to create our own dataset from scratch using Python. Don't worry if you are a complete beginner, I will explain every single line of a code, why we are writing it and how it works. So let's get started. The first thing we need to do is import a library called Pandas. What exactly is a library? A library is a collection of pre-written code created by other developers. Instead of writing everything ourselves, we can use these ready-made tools to make our work easier. Why we exactly take Pandas? Pandas is one of the most important libraries in Python for working with data. It helps us create tables, read CSV files, save CSV files, and it filters rows and columns, and it analyzes the data. In machine learning, almost every project starts with Pandas because our data is usually stored in tables. We write Pandas as PD is a short instead of typing Pandas. We use PD for entire code. It saves time and is the standard convention used by Python developers. Next, we are importing another library called NumPy. NumPy stands for Numerical Python. It is mainly used for mathematical calculations, arrays, random number generation. In this project, we are creating a dataset artificially, so we don't have real user information. Instead, NumPy will generate realistic random values for us. For example, it can create random screen times, random ages, and much more. Just like Pandas, we give it a short name using as NP, so our code is shorter and easier to read. Now we are creating a variable called rows. A variable is simply a container that stores a value. Here the value is 50,000. This means our dataset will contain information for 50,000 different users. You might wonder why I selected 50,000. I chose 50,000 because it's large enough to create a realistic dataset for practicing machine learning. A large dataset gives the model more examples to learn from, which often helps it identify patterns more effectively. For learning purpose, you can choose any number such as 1000, 10,000 or even any big number. I selected 50,000 because it provides a good balance between dataset size and performance. Now that we have decided how many users our dataset will have, let's start creating the features for each user. Now we are creating a dictionary. A dictionary in Python stores information as key value pairs. Here, each key will become a column in our dataset. That value will contain the data for that column. Think of it like an Excel sheet. Each column has a name such as age or screen time. Each row represents one user. By the end of this dictionary, we will have 20 columns describing each user phone usage. Our first feature is daily screen time. This represents how many hours a person uses their phone each day. Why is this feature is important? Because people who spend more time on their phones are generally more addictive, likely to develop addictive habits. Now let's understand the function we are using. function generates random numbers that follow a normal distribution. A normal distribution means most values are close to the average, while very low or very high. Values are less common. This is more realistic than generating completely random numbers. Now let's look at the parameters. The first value is 6, is the average. We are assuming that average person uses their phone for about 6 hours a day. The second value is 2, is called the standard deviation. It controls how much the value vary. So some users may have for 4 hours, some 6 hours and some also 8 hours. Finally, rows tell NumPy to generate these values for all 50,000 users. These limits the generate values between 1 and 12. Without this limit, NumPy might generate unrealistic values such as negative screen time or 20 hours per day. Using this ensures every value stays within a realistic range. Our second feature is app sections. This tells us how many times a user opens different apps during one day. For example, someone who constantly checks Instagram, WhatsApp or YouTube will have higher number of app sections. Here we are using randint. Randint means it stands for random integer. Here because app sections are counted as whole numbers. The first value is 10. It is the maximum number of sections. The second value is 150. It is the upper limit. The last parameter rows. Means we generate our one value for each of our 50,000 users. Our next feature is social media usage. Social media usage. This feature records how many hours a person spends on social media every day. Example includes Instagram, Facebook, Snapchat, X and similar platforms. The minimum value is, here we are taking function randint. Here minimum value is 0 because some users may not use social media at all. The maximum is 7 hours. Since we are using 0 to 8 generates, but actually it generates value from 0 to 7. This feature is very important because higher social media usage often increase the. This feature measures how many hours a person spends playing games each day. Gaming is another activity that can significantly increase. Again we are using randint because we are generating whole number hours. Again we are using randint because we are generating whole number hours. This feature stores the number of notifications a user receives each day. Notifications are important because every notification encourages a person to check their phone. We are using a normal distribution again. The average is 120 notifications per day. The standard deviation is 60, meaning some users receive fewer notifications while others receive many more. Finally, click 10-300 ensures the number of notifications stays between 10 and 300, which makes the data more realistic. So far, we have created the first 5 features of our dataset and learned how NumPy generates realistic data using both normal distribution and random integers. If you enjoy this video, don't forget to like, share and subscribe to Little Galaxy. Since I am continuously learning and improving, your feedback means a lot to me. If you notice anything I can explain better or improve in future videos, please let me know in the comments. I read every comment and your suggestions will help me create better content. Thank you for watching and I will see you in the next video. Keep learning, keep going. Bye everyone.